So when you hear of momentum, momentum is simply mass moving or mass in motion. So momentum is given as a product of mass and velocity. That's linear momentum. Okay? So the symbol for momentum is P. Momentum is given by mass multiplied by velocity. We know that mass is measured in kgs. Velocity is measured in meters per second. Therefore, momentum is measured in kg meter per second. That's a unit. That's our unit for momentum. Kg meter per second. So let's say you have got an object. You have got a 20 kg object which is moving, we can say at 10 meters per second. You want to find its momentum. So the momentum of this object, momentum is simply mass multiplied by velocity. So the mass 20 kg multiplied by velocity, which is 10 meters per second, that gives you 200 kg meter per second. Okay, so just make sure that when you are calculating the momentum of an object, the mass should be in kgs, velocity should be in meters per second. Right units are very important in science. So if you get to use wrong units and you don't connect them like that, you might end up getting wrong things. Okay, so momentum, mass times velocity. Mass in kg, velocity in meters per second. Now, I know you guys have learned laws of motion. Newton's second law, first law, third law. Now, according to the third law of motion, Newton's third law of motion, if you remember what it states, Newton's third law of motion tells us that the reaction force on an object or the action force on an object is equal to the reaction force. So if I apply, let's say, a force F on an object, that object is going to hit me with that same force F. The only difference is that now the sign is going to be negative because of opposite direction. Okay, so to every applied force there is a reaction force. Any force that you get to apply, there is a reaction. So to a force applied, there is a reaction force in the opposite direction. There's a reaction force in the opposite direction. I hope you guys are able to get that because this is very important.
Dimas, please, you can switch off the video.
Alright, so look at this. Let's say I've got a person here. Okay, this person is moving. Let's say is running at 20 meters per second, and this person is 10 kg. And then he finds someone who is at rest. So this one I'm saying at rest because they are not moving. Okay, let's say this one is 5 kg. So what is going to happen is that this one who is moving is going to apply a force on this one. Alright, the one who is moving is going to apply a force on the one who is not moving, and the one who is not moving, the same force that the person who is moving has applied on or exerted on the one who is moving is the same force that is going to come on this one, but opposite in direction. So the question comes to say, why is it that when you hit yourself, like you hit with your punch in a wall, you are going to feel pain? So that just lies in the same concept of momentum and force and third law of motion. So when you hit a punch in a wall, the same force with which you have hit the wall is going to hit you back. Okay, there's going to be a reaction force from the wall, and the same magnitude with which you've hit the wall is the same magnitude you are going to experience in the opposite direction. This is why you get to feel hate when you get to hit yourself on a wall. Right, so we're going to understand that. Now, basically, this is momentum. Now, when you are talking about momentum, there is a force that gets to result. Okay, there is a force that gets to result when you get to hit a person, or when momentum gets to change. What do I mean by momentum changing? Let's say, for example, you are here, you are not moving. Here is the 20.
Yes,
Yes, please.
you can tell that Dimas to switch off the video where display blank.
Oh, it's
Yes,
still on. Uh, okay. So when you get to switch on the video or the mic, even network is disturbed. So just make sure that you get it off. Right. Thank you. Okay. So let's say that we have got this person here who is at rest. Okay. At rest meaning there's no movement. And then you start moving. He starts moving. And maybe let's say after 5 minutes, the same person is moving now at 10 meters per second. So what are you able to see here? There is a change in velocity. Okay, so because there is a change in velocity, you expect to have change in momentum. You expect to have change in momentum. Right, just give me a moment. Just a moment. So just take note of what I've mentioned. You are at rest initially, all right? You are at rest. And then after 5 minutes, you started running, and then after 5 minutes, you are now moving at 10 meters per second. So because your velocity has changed, that means that your momentum has also changed. So here we're going to find first initial momentum. Let me call it P1. That's initial momentum. That is going to be given by what? Mass times the initial velocity. Let me call it velocity 1. So the mass of the person is 20 kg. But the velocity of this person initially, remember, is at rest. So the velocity that he has is what? Is 0. Okay, when someone is at rest, the velocity is 0. And 20 times 0, that is 0, means that anything that is not moving doesn't have momentum. And then the second momentum, let me call it momentum 2, is going to be equal to mass times velocity 2. The mass of the person,
video. You can switch.
uh, please, there's someone who is just calling me, so that's why you can see a bit of pausing.
And also the second video.
Okay, I hope you can. Are you able to see it now?
Yes, it's everything's okay now.
All right. So we are saying to find the second, like the momentum after 5 minutes, momentum is mass times velocity. The mass of the person doesn't change after riding, so the person is still 20 kg. Okay, now but the velocity is now what? 10 meters per second. So I mean that the second momentum is 200 kg meter per second. So here you are able to calculate change in momentum. How do every time you hear of change, change is given by final minus initial. So I'm going to say momentum 2 minus momentum 1. So this is going to be 200 minus 0, which will basically be 200. So the unit is kg meter per second. So what I want you to realize is every time there is change in momentum, there is going to be what is called impulse. So we define impulse as a change in momentum. Okay? Impulse is defined as a change in momentum. So we are going to use the symbol I. So impulse is equal to change in momentum, like that. So take note of this. But how does this come anyway? How does this come? Because I want you just to understand. At times I might not ask you to derive how it comes, but understanding is key. So it all comes from, remember, Newton's second law of motion. Who can tell me Newton's second law of motion, like the equation for Newton's second law of motion?
Force equals to mass times acceleration.
Yes. So force is equal to mass multiplied by acceleration. We also know that acceleration, who can I ask here? How do you find acceleration? Anyone?
Acceleration, the formula.
Yes, a formula. Okay, so where there's acceleration, I'm going to put change in velocity divided by change in time. That is acceleration. And then from here, I'm going to multiply. Okay, I'm going to multiply the change in time with a force there. So what we are going to have is force multiplied by change in time is equal to mass multiplied by change in velocity. Now, this force multiplied by change in time is what is defined as impulse. And remember, momentum is mass times velocity. Now, when velocity is changing, meaning that momentum is also going to be what? Changing. Okay? And then mass times change in velocity is going to be change in momentum, since mass times velocity itself is momentum. So this is how this equation comes. So impulse is equal to change in momentum. What is impulse? Impulse is simply force multiplied by the change in time, and that is going to be called change in momentum. How do you find change in momentum? It is final momentum. Okay, change in momentum is given by final momentum minus initial momentum. So this will give you force change in time being equal to final momentum is mass multiplied by final velocity. Initial momentum is given by mass initial velocity. So this will give us force change in time being equal to, so since you can see that mass is not changing, you are talking basically about the same object, so we are going to factorize out mass. So remain with final velocity minus initial velocity. Final velocity minus initial velocity is what we call change in velocity. Okay, this is just mass multiplied by change in velocity. So this is the same equation that we are able to see this side. So this is how you get to determine momentum. Okay, the relationship between momentum and impulse. Now, what do I want you to realize here? Every time you have got uh, momentum, you need to have velocity. I hope you can get that. Okay, every time you have got momentum, you need to have velocity. Because if something is not moving, meaning that its momentum is zero. And every time you have got velocity, you are going to have kinetic energy. How do you find kinetic energy? Kinetic energy is given by half mv squared. So every time you have got momentum, you are going to have kinetic energy. But at some times you can have momentum but you don't have impulse. Why do you think so? The reason is simple. Impulse is change in momentum. Let's say you were moving at 20 meters per second. After 1 hour, you are still moving at 20 meters per second. There is no change in velocity, therefore there's not going to be any change in momentum. And because there's no change in momentum, you're not going to have any impulse, because impulse is defined as change in momentum. Please take note of that because I've seen some questions like that. Every time you have got momentum, you always need to have. Okay, so take note of that. Do we have anyone who has a question over what we've said? Anyone who has a question over what we've just mentioned here? Okay, I'm guessing we are okay. Now, let's say we have got an object. Uh, yes, Mao. I don't know the name here which is showing. I don't know how to pronounce your name. Yes, go on. Go on. Mulpe. Let me say Maupe. Yes, you can say, you can open your mic and be able to speak. Maupe. Yes.
Hello.
Yes, I can get you.
My question is on just on how to derive the what the equation for impulses. You can come again over that.
Okay. All right.
Yes.
So we are saying, according to Newton's second law of motion, force is given by mass multiplied by acceleration. Okay, we also know that acceleration itself is given by change in velocity divided by change in time. And then I'll just multiply this change in time with the force this side. So that is going to give us force multiplied by change in time, and that is going to be equal to mass multiplied by change in momentum, velocity I mean. Now force multiplied by change in time, this is what we call impulse. And you know that mass times velocity is momentum. Now since this is mass times change in velocity, then this is going to be change in momentum. So this is the impulse momentum theory. Impulse momentum theory. This is the one. Is it okay now?
Yeah, very clear.
All right. Okay. So let's look at now. Before I write what I wanted to say, you need to know, friends, that in whatsoever kind of collision, so when you have got things colliding, for example, you have a car that is moving in this direction, another car moving in this direction, or anything that gets to collide, please know that momentum is always conserved. Okay, that is called the law of conservation of momentum. In any kind of collision, momentum is always going to be conserved. It doesn't matter what kind of collision. Take note of that. Right. Now, let's say you have got a block. Let's say this block is 70 kg. And then due to maybe explosion or something like that, it breaks somewhere there, such that one piece goes in this direction. Okay, one piece after breaking, let's say this is a 20 kg piece, it goes in that direction, and then another piece which has remained goes in this direction. Obviously, if the 20 kg piece has gone that direction, obviously it should be a 50 kg piece. Now let's say the 50 kg piece which is going in this direction is moving at 10 meters per second. Okay, now the question is, find the velocity at which this piece is going to be moving after this explosion. That's the question. Find the velocity at which the other piece is going to be moving. Now, since we have said momentum is conserved, we are going to say initial momentum is going to be equal to final momentum. Okay, initially we add this object and we are taking that it is at rest. So the momentum is going to be mass multiplied by velocity initially. And this is going to be equal to, here we are going to have two pieces. Let me call this as M1. Let me call this as M2. So at the end, the final momentum is going to be a combination of these two objects. So I'm going to have momentum 1 multiplied by the velocity 1, and then plus momentum, mass 2 multiplied by velocity 2. So get the momentum of this one and the momentum of this one. That is what you, if you add them, that will give you the final momentum. And then the initial momentum, just the object that you started with. Okay? And then the mass of the object that we started with initially, that is 70. The velocity, remember it was at rest, so velocity is 0. That is going to be equal to m1, the mass is 50. The velocity, now if you want, you know that this is the negative x-axis, right? Mostly you are going to take it like that. So you are going to attach a negative here because this mass is going in the negative x direction. But if they've given you this as positive, it's not a crime, you can use it like that. So you say 10. And then plus mass 2. Mass 2 you can see that is 20, but you don't know the velocity, that is v. That's what you want to calculate. 70 times 0, that is 0, which is going to be 50 times 100, which is 500. That is plus 20v. I'm going to take the 20v the other side, becomes negative 20v. That is going to be equal to 500. So to find v, divide both sides by negative 20. So that will give you negative 25 meters per second. Now the question is, why would the velocity be negative? So if you take that velocity going in this direction is positive, then going in this direction is going to be negative because they are moving in opposite directions. That's just Newton's third law. They are moving in opposite directions, so that's why you need to expect a negative sign on the other velocity if the other one is positive. So that is the velocity at which it will be moving. Now, can you realize that for the bigger mass, it will move at a smaller velocity, and then the smaller mass, it will move at a bigger velocity? Can you realize that? This just confirms Newton's second law of motion. You know that force is mass times acceleration. When that acceleration is given by force over, acceleration is going to be given by, actually, yes, force over mass. So you see that when you increase the force, you are going to reduce the acceleration because the denominator becoming bigger means that the friction will be becoming smaller. Alright, so is this okay? Do you have any questions before I give another example? It's okay? Yes, yes, Karist.
Okay, what if now you are not given the mass of the other particle?
If you are not given the mass of the other particle, this is just simple maths. You just say 70 minus the one you've been given, then that will be the mass of the other one. Yes. So you actually apply the principle of momentum when it comes to those rockets which go in space. Okay, like the rockets which get to move in space. Let me give an example. You have got this rocket. So what happens is, before this rocket goes up, let me remove this first. That is called rocket propulsion. Rocket propulsion. Even insects, those insects which jump, they use the same principle here. Okay, so for this rocket to go up, there is a gas that has to be bent. So what is going to happen is that the gas that is bent is going to be pushed down. Okay, like it's pushed down. That's why you see the fire comes out down there. Okay, when this gas is bent, the fire comes out like that, or maybe the water or something that has come out. That is going to make this one to be pushed up. That is the thing. Newton's third law of motion tells us, if you have got a force going down, there should be a force pushing up. There's a reaction to every action. There is a reaction. So this is actually the application of momentum. Okay, so let's say the gas that you are burning is, let's say, 20 kg. Okay, you are burning the gas, that is 20 kg. And then as you get to burn it, it is pushed down, like the gas is released or pushed down at 15 meters per second. And then you have got now this jet, which is, let's say, 200 kgs. So I want to find the velocity at which is going to be pushed up. So you use also the application of momentum. So initial momentum is going to be equal to final momentum. It should be initial, this is going to be fine. So the initial momentum is given by mass multiplied by by velocity, and that is going to be equal to, so let me call the rocket as m2, and then I'll call the mass which is burning as m1. So this is going to be m1 v1 plus m2 v2. So the mass, initially the liquid or the gas that has to be burned is together with the rocket. Okay, so initially the mass is going to be a combination of 220. That is going to be 220. Now initially the rocket is not moving, neither is the mass released down at the beginning, so means that velocity is 0. But at the end, m1, the mass of the gas which is being released, is 20. The velocity at which it is moving, so I'll take going down, like this is the negative y-axis, so I'm going to take this velocity as the negative because it's negative y-axis. Okay, and then plus the mass, now the one which is going to be pushed up, that is m2, the mass is 200, and then multiply by v, that's the velocity we want to find at which it is going to go up. Now this is going to give you 0, right? So that is going to give us 0. So 0 is going to be equal to 20 times negative 15, that will be negative 300, and plus this is going to be 200v. Take now the 300 the other side, or the 200 the other side. I'm going to have negative 200v is equal to negative 300. Divide both sides by negative 200, so v is going to give you 3 over 2, okay, which is the same as 1.5 meters per second, meaning that this is the velocity at which the rocket is going to be pushed up, 1.5 meters per second. So you see that things which were connected initially, the initial velocity is always 0, right? So meaning that this equation, actually, where there is mv here, I'll just put 0, and I say this is going to be equal to m1 v1 plus m2 v2. Now notice that Lista, yes, go on. Lista, your hand is up. You can open your mic and be able to speak. Okay. Caristo, your hand was also up.
Yes. How can you know that this, like, that velocity will have a negative?
Okay,
This one is that.
so the reference point is just a Cartesian plane. This is positive. This is positive because that's a positive y-axis and the positive x-axis, and this is going to be negative. This is also going to be negative. So in other words, you take the west and the south as negative, the north and the east as positive, just considering the x or y plane. That's okay?
But why, like, for the first exam, we are positive?
Yes, so I just decided to use that. It's the same when I use positive 15 here. It's not a crime, meaning that the answer I'm going to find here is going to be negative. All we are saying is that if this one going down is negative, the one up will be positive. If the one up is negative, the one down is going to be positive. They have opposite signs. So in a case where they've given you like going down is positive, take it like that, then means going up is going to be negative, like that.
Okay, I have understood.
All right. So I was saying the 220 is a combination of the 200 kg and the 20 kg. Like initially, this gas which was burning was in the rocket before it was released. So they were together like that initially. That's what you're able to see. So that's where the 220 came from initially. So now from this formula that I've written here, so every time you have got a propulsion, like something is being pushed up, now one velocity is going to always be negative, okay? So this is going to be m1. This velocity, you can take any one of them, is going to be negative. So this is going to be negative because one has to move down, the other one has to move up. And then plus m2 v2. So since this is negative, I'll take it the other side of the equation. So it becomes m1 v1 is equal to m2 v2. So this equation becomes important when you're talking about things that are like where there's a propulsion, like a rocket or an insect is being pushed up. So just say the mass of what is being released and the velocity at which it is being released is going to be equal to the mass of what is going to be pushed up times the velocity at which is going to be pushed up. So any term that is missing, you are able to calculate direct like that.